Good morning, class. Today we are going to start a new section of our syllabus, that is organic chemistry. In your previous classes, we discussed about inorganic chemistry. Now we'll discuss about organic chemistry. This organic chemistry portion is very important in class 11. So we are going to study about the basics of organic chemistry, because in class 12 we have around 7 chapters based on organic chemistry. So it is important to know the basic concepts in organic chemistry. So today we'll start. So we'll start with the general terms like organic compounds, catenation property, and how to write the bond line formula. Now, so organic compounds are basically that compounds which are obtained from living organisms. Example, plants and animals were called organic compounds because they obtained from plants and animals, and they are found in plants and animals. Organic compounds. Okay. Inorganic compounds, whereas inorganic compounds are the compounds which are obtained from mineral resources, are called inorganic compounds. So as we came to know about organic compounds, they are obtained from living organisms, plants and animals, whereas inorganic compounds obtained from non-living things, we can say mineral resources. They are called inorganic compounds. Now, the carbon has got a very unique property, and that property is called catenation property. And the catenation property defines itself as the ability of carbon atom to form long chains and large rings is called catenation. So carbon is the only element that has got the property to link with each other to form a long chain as far as it's possible. So it can form a straight chain, or it can form a branched chain, or it can form a cyclic chain. Okay. Now, that property we call catenation property. Next, how we can represent any organic compounds. There are different forms of representing the organic compounds. The first is electron dot formula, which we have already seen in the chapter chemical bonding and molecular structure, how to write down the Lewis dot structure. Say for example, methane. In methane, we have got a one carbon atom in the center, and we have got 4 hydrogen atom. 1 2 3 4. Just correct it. This is hydrogen atom, and each hydrogen has got one electron, and carbon atom in the outermost we have got 4 electrons. So each each hydrogen atom with 1 electron will pair with 1 electron of the carbon atom and will form a covalent bond. Okay. Similarly, in ethane it will look like this. This is the ethylene having a double bond. Okay. Now, this is called electron dot formula, since we represent the over here the compound in electron dot. Okay, this one. The next is graphic formula. In this type of representation, a straight line is used to represent each said pair of electrons as illustrated below. Now in graphic formula, we just have a straight line between the sharing pair of electron. Say for example, in methane we have got 4 hydrogen atom, and each hydrogen will form a single bond with carbon atom, so it can be shown in this way. Similarly, ethane in this way, and ethylene in this way, ethylene or ethene. So this we call as a graphic formula. So we can either represent organic compounds in electron dot formula or graphic formula. Next, we can also express the organic compound in condensed formula in this form. Graphic formula, if it is like this. So say for example, the condensed formula means writing that in the condensed form, in the smallest form, we can say. Say for example, over here C and 4 hydrogen, so it can be written as CH4. Okay, that will be the condensed formula. The ethane can be written as, this C has got 3 hydrogen, so it can be written as CH3. This carbon also have got 3 hydrogen, it can be written as CH3, so CH3 CH3. Similarly, if you have got propane with a 3 carbon atom, it can be written as CH3 CH2 CH3. Got it? So this is how we write the condensed formula. Okay. Next, a very important formula is called as bond line formula. It is a simple, brief, convenient method to represent the structure of an organic compound. In this type of representation, the bond between carbon atoms are represented by lines. So in this, we represent the organic compounds through only lines. Only lines you will see. A single bond is represented by single line. A double bond is represented by two parallel lines, and a triple bond is represented by three parallel lines in this way. Okay. The intersection of lines and end of lines represent carbon atoms unless some other atom is written in. Hydrogen atoms are not shown, and it is assumed that the necessary number of hydrogen atoms are present wherever these are required to satisfy the tetravalency of carbon. Okay. We'll see how we can write down the bond line formula. Say for example, we have got this compound CH3, CH3, CH2, CH3. So first we'll write down the structure for this. Say for example CH3, then to this carbon atom we have got one CH3, so we have written it over here. Then we have got CH2, CH2 and CH3 like this. Okay, now the structure is like this. Okay, now we'll remove all these CH3 and CH2. Okay, so the bond line formula for this is written in this way. This is CH3, this is also CH3. Over here there are three bonds, so it will be only CH. Over here it is CH2 because we have got only two bonds, and this is CH3. Okay, so this one line represents it is a CH3. If there is an intersection of two lines, it is CH2, and if there is an intersection of three lines, it is only CH. That you have to understand. And if we have got four lines over there, then it is only carbon. Okay, this is how we represent the bond line formula. Similarly, other example we have got CH3, CH, Cl, CH2, CH3. So first we'll write down the structure like this. CH3, then we have got CH, then to this Cl will attach, then CH2, then CH3. Fine. Now in this this, as we say, CH3 can be written methyl can by a line. So this is CH3, this chlorine over here, this is CH, then CH2, then CH3. Okay, this is the bond line formula. One more example. So we have got CH3, CH3, double bond CS, then CH2, CH3. Okay, now this can be represented in this way: CH3 to this carbon, then CH3, double bond CH, CH2, CH3. So we represent a line like this, like this. You can count number of carbon atom: 1, 2, 3, 4, 5. It's straight line. So 1, 2, 3, 4, 5. Fine. Now at two carbon atom we have got a double bond, so we place a double bond, and to this we have got one methyl group. So one methyl group. Okay, so this is 2 methyl pentane. This is how we represent the organic compounds in bond line formula. Okay, now assignment for today, assignment number 10. Question number 1, differentiate between organic and inorganic compounds. Question number 2, define catenation. Question number 3, give the bond line representation of the following compounds. Okay, you need to represent in the bond line form. Okay, B, this also you have to represent in bond line form: CH2 double bond CH, CH2, CH double bond CH2. C, CH3, C, CH3, CH3, CH2, CH3. And finally D is this one: CH3, C, CH3, this is H, a C, CH3, H, CH3. Okay, so complete this assignment and send it in my mail.